Hi, and welcome to the 10 square meter workshop. Recently, I've been thinking about honing jigs. The apparatus used to hold your blade of your plane or chisel at the correct angle while honing on the stone. Up till now, I've been using one of these single wheel honing gauges that has a roller which you use to move the blade up and down the stone. But they're not very satisfactory. Not only are you rolling on the stone itself, you can't get to this end, so you have to turn the stone round from time to time to use the whole surface. And of course, it's just a straight back and forward motion. You can get a bit of side in it, but not a great deal. There are designs that have a wheel on each side to avoid having to roll on the surface. The problem with that is you've got 2 points of contact here and 2 points of contact here, the ends of the blade, and keeping all four in the same relationship requires very careful adjustment. Some, of course, say they can achieve this task by hand holding, and while I've got some sympathy with that, I'm not one of them, and I have some doubts about how accurate the micro bevel can be put on in this manner. So, can I produce a better jig? Can I form a better mousetrap? Well, let's give it a go. I recently saw a design that involved having a post and a rod that held the blade and allowed you to pivot it to move it across the stone. This allows you to use the full length of the stone, but it makes it a bit difficult. You've got to keep moving the stone in and out to use different surfaces. What is needed is a mechanism that holds a constant height, but allows motion in two planes, so you can get over the whole surface. At the heart of this design are these linear bearings. Think of a ball race, but one that allows it to move linearly as well, very smoothly. So it both rotates and moves. And it's a pretty accurate hold. What persuaded me to go ahead with this project was not just that I had steel tubing, which was exactly the right fit, but I also had this piece of aluminium tube. And this is a tight sliding fit for the bearings themselves. This saves me a great deal of work. 2 bearings in the sleeve, and I have a very smooth, very rigid setup. It also needs to rotate horizontally, and for that I shall use a conventional ball race. The next part I do need to machine out of this chunk of aluminium bar. One end is turned down until it's a press fit for the bearing. The other end is simply faced off, before mounting it in the milling machine, with the boring bar set to the diameter of the bearing sleeve. It's now a matter of taking successive passes. The first pass has straight sides, which shows that the piece is being held square in the vise. This is very important. Here it is after 3 millimeters, only another 12 to go. Finally, after 9 millimeter deep, I decided it was rigid enough as it was, and the finish was good, surprisingly good. The 2 parts go together like this, but I need to fit a bolt to hold them together. After centre drilling, I drilled 5 millimeters through the centre of the side. While the base is centre drilled 4.2 millimeters and then tapped 5 millimeter, and the 2 are brought together. It was then split again for a bit of cleaning up and to press in the bearing. Nice tight fit. The bearings are held into the tube by some grub screws and a bit of Loctite. The base needs to be both flat and waterproof, so I should be using this piece of corian. It should be ideal. and then made a clamping plate. This is 8mm aluminium. clamped and the 4 mounting holes drilled through, the 4 holes in the clamp were tapped 5mm. The back of the board was drilled clearance and counterboard to take cap head bolts. I now have an arm which can move anywhere over a surface and yet can still rotate, but it remains at a fixed height. The vast majority of items being sharpened are, of course, chisels and plane irons. Most honing guides try to use a single device to grip both, the chisels in a bit and the plane irons in the wider. Plane irons come in all sorts of shapes and sizes, and the width varies a lot, and some are not even parallel sided. But the one thing they all have in common is this middle slot, used for clamping it in the plane. So, if it's good enough to clamp in the plane, why not use it to clamp in the honing guide? To that effect, I've made this plate with some mounting holes. I've used 3 of them to deal with different length irons, and it clamps simply together. I now need to make a knuckle or hinge to join the plate to the arm. This was made by mounting a piece of 19mm square bar in the 4-jaw chuck. And the end turned down until it was a sliding fit for the end of the shaft. Parted off, it's into the mill to be cross drilled. I'm drilling 4mm because I have some 4mm rod. The mounting plate I had already cross drilled before cutting the slot. Here you can see how accurately a mill can drill a cross hole, one side and the other. The swivel head is held in place on the shaft by a 4mm bolt. So with everything assembled, how does it work? Well, first of all, you put your level gauge on the stone and zero it. Then put it on the plane iron and move the iron up and down and tighten when you've got the value you want, in this case 27 degrees. Applying pressure to the iron, you then move it around the stone. You can do figure of 8s quite easily, but quite frankly I find the easiest is to move it back and forwards, extend it a bit and do it some more. Or of whatever pattern you like. And you can rotate the blade through 180 for visual inspection. This is a few minutes later. I've now had a bit of experience on it, and for grinding in a new blade I reckon the best technique is this. It is really very easy to do and gives you a lot of confidence that the angle is staying the same the whole time. This is a brand new Stanley blade, and it certainly isn't starting off at 27 degrees. In fact, it's somewhat less than that, 28, 29 I reckon. Certainly not the 25 marked on the blade. Okay, a couple of days have now passed, and I've made a couple of minor improvements to make it easier to use. The first is a couple of swing down tabs, which allow me to clamp it in my Maxim vise. Nice and steady. And the other is I've fitted a couple of dowels and a couple of eccentrics so it can be clamped firmly in position. And the same clamp works on my ceramic stones. I've also had time to sharpen a couple of irons, one from scratch and the other a resharpen. So, how did I find it? Actually, it's not only the fastest and most accurate, it's the easiest to use from a honing point of view that I've ever experienced. I think I can pretty much call this a success. Well, that sorts out plane irons, but what about chisels? Well, I've made this jig to hold them. It fits on with a single butterfly nut, like so. The chisel just fits in and clamp down. the still room to fit the level gauge. There's inherently less room to extend the chisel, so I made a riser plate which drops into place, and with this I can cover a range of 24 to 35 degrees, which covers all the chisels I need. In addition, I made a 2.5mm riser plate. That covers the difference in height between the ceramic and the diamond pads, which means if I start off with diamond, I can then take that out and replace with ceramic, and it's the same height, so no change in angle. On top of that, I made 2.8mm acrylic risers. This makes half a degree difference, ideal for micro bevels. And the last step, make a home for everything so it doesn't get lost. And so there we have it, my Hone Master honing jig. It is, I believe, much better than any commercial version I'm aware of. It's a bit complicated to make, but it's very simple to use, and I have great confidence in the angle it produces. That's all for this time. Why not subscribe for more, and I'll see you next time. Bye for now.